In 1831, Michael Faraday discovered that a changing magnetic field near a coil of wire will produce electric current in the wire. In 2012, the Barrington High School AP Physics C class built a wind turbine that utilizes this discovery to convert kinetic energy of the wind into electrical energy.
The wind turbine has two main components: the stator, a collection of coiled wires, and the magnetic rotor, steel discs with 12 magnets each. The stator is a collection of coils that produce the voltage when the magnets pass by. This generator uses 9 coils of wire, and each coil has exactly 70 windings. To make each coil similar in size, we first made a coil winder out of some plywood scrap and laboring stands. Working in groups of 2, we turned the crank 70 times with the other person adding tension to produce tightly wound coils.
These coils were arranged in a circle, then wired so that the 3 coils work together in series, then in parallel with the other group coils.
The coils will be cast in a 2-part epoxy to form a donut-shaped disc. A mold was made out of plywood to hold the coils while the epoxy was poured in around them. It had to be waxed down and greased up to allow the cured epoxy ring to fall out of the mold.
The magnet rotors rotate with the turbine blades. They are placed on either side of the stator to provide the magnetic field that passes through each coil.
Each rotor contains 12 neodymium magnets. The magnets are arranged so that the north and south poles alternate as you go around the motor. This causes the field to change direction through each coil 12 times every revolution.
The magnets are placed with the aid of a plywood template. Students carefully arrange the extremely strong magnets around the perimeter of a steel disc. The disc is then set in epoxy resin to make 2 solid magnet rotors. A fiberglass fabric provides extra strength.
The generator will produce 3 alternating currents. This current is forced to flow in one way by passing through the rectifiers. The rectifiers are mounted on an aluminum heatsink, since these components tend to heat up. Also wired in the circuit board is a kill switch that immediately stops the turbine from spinning by shorting out all of the phases.
The generator is finally assembled by first connecting a trailer wheel hub and one of the magnetic rotors. The hub comes with lug bolts that must be knocked out and replaced by larger bolts. The rotor is carefully connected to the hub while the bearings get a generous coating of grease. The first magnet rotor is placed on the turbine pit. The stator ring is installed next. Finally, the last rotor is placed so that the stator is sandwiched in between.
When the steel rotors rotate, a changing magnetic field near the coils of wire changes direction 12 times in one rotation.
The blades were carved by hand. Students first chiseled out most of the wood. Then they sanded it down.
Students performed force analysis to determine the size of the cables to handle the wind loads. The tower was raised without the turbine to adjust cable lengths. Then, the tower was lowered, the generator was installed, and the tower was raised.